I'm going to review the concepts on the Module 4 test in order to prepare you. So in Section 1, we were talking about whether or not a function was linear or nonlinear. So given the equation y equals x squared minus 3x plus 1, if x equals 2, find the y value. So just plugging in a value for x. So y equals 2 squared minus 3 times 2 plus 1. 2 squared is 4. Negative 3 times 2 is negative 6 plus 1. 4 minus 6 is negative 2. Negative 2 plus 1 is negative 1. Okay. We also were determining whether or not something was a function. The best way to do that is using the vertical line test. So given a graph, determining if a graph is a function. So if you draw, with the vertical line test, if you draw an infinite number of vertical lines, if any single one of those vertical lines touches the graph in more than one place, it is not a function. So in this first example, it is not a function. Multiple vertical lines are going to touch in more than one place, but all that matters is that one touches in more than one place. Whereas with our second graph, any vertical line I draw is going to touch the graph in only one place, so this one is a function. We also looked at tables to see whether or not a table represented a function. So when you're looking at a table, you're looking for any repeated x values. And if we see here, we have a repeated x value in 5. 5 goes to 1 and negative 6. So it's not a function because there are repeated x values. Okay. Can't have an x value going to two different y values. In section 2, we used a table to look at linear equations. So does the table represent the linear equation y equals negative 2x plus 5? So the easiest way to check this is to start plugging in our x values into our equation and see if we get out the corresponding y values. So start with y equals negative 2 times negative 4 plus 5. Negative 2 times negative 4 is 8 plus 5 is 13. And 13 does not equal negative 3. So the answer is no. If it had equaled negative 3, I would have needed to keep checking values to make sure that it matches. Just because one of the values match does not necessarily mean that the table represents the linear equation we're given. You needed to check all of the values. Whereas on the reverse side of things, if there's one value that doesn't match, I can automatically say that it does not represent the equation. In section 3, we took a look at slope. So just remember, slope between 2 points is y2 minus y1 over x2 minus x1. So we want to find the slope between the points 1, negative 5 and negative 2, 10. So I'm going to label 1, negative 5 as x1, y1 and negative 2, 10 as x2, y2. So my slope is going to be 10 minus negative 5 over negative 2 minus 1. And 10 minus negative 5 changes into addition, so we get 15 over negative 2 minus 1 is negative 3. And 15 over negative 3 is negative 5. If you can simplify a slope, please do. Next, we have the equation 4y minus 2x plus 8, and we want to identify the slope. So there's also the equation y equals mx plus b, where m is the slope. So if I'm given an equation, I want to try to get it in this form to identify the slope. So 4y minus 2x equals 8. My first step is going to be to add 2x to both sides. So we get 4y equals 2x plus 8. Then I'm going to divide through by 4. And we get y equals, now 2/4 is the same thing as 1/2 x plus 8 divided by 4 is 2. So the slope is the number in front of x, so my slope is going to be 1/2. Next, we want to talk about identifying slope from a graph. So the easiest way to do that is to pick two whole number points. And if the y-intercept is a whole number, that's always a good place to start. So I found 2 points. Next, I want to figure out what I have to do to get to those 2 points. So I have to go down 2, and I have to go right 3. So down 2, right 3 is a slope of -2/3. Because remember, slope is rise over run. You could have also used the coordinates 0, 3 and 3, 1 and used the formula to find the slope between the 2 points. Okay. Next, we want to talk specifically about slopes of vertical and horizontal lines. So the slope of a vertical line is undefined. And this is because if you were finding the slope between the 2 points, the x value would be the same and you would be dividing by 0, which we cannot do. So that's why it's undefined. Whereas the slope of a horizontal line is 0. And this is because the y values are the same, which means you get 0 divided by a number, and 0 divided by anything is always 0. So you get 0 divided by a number. So the difference between vertical and horizontal lines is the placement of 0 in the fraction. In section 4, we took a look at writing equations of lines, and this looked at a couple different ways. So the first is writing an equation of a line given the slope and a y-intercept. So we're going to go back to the y-intercept form, y equals mx plus b. So remember, m is the slope and b is the y-intercept. So that's the great thing about slope-intercept form. So if I know my slope, we can do y equals 1/3 x plus, minus, because our slope is negative, y-intercept is negative 10. Okay. It's not always as nice as given the slope and the y-intercept and putting in that form. We can also be given 2 points, and we want to write the equation of the line that passes through the points 2, 3, and -1, -3. So my first step is going to be to find the slope. So I'm going to label my points x1, y1, and x2, y2. So I'm going to do -3 minus 3 over -1 minus 2. So -3 minus 3 is -6. -1 minus 2 is -3. And -6 divided by -3 is +2. So I now know my slope. So we know we have y equals 2x plus b. Now I need to solve for my y-intercept. And the way I'm going to do that is by plugging in one of my 2 original points. So I'm going to plug in 2, 3 since it's positive. So I'm going to plug in 3 for y, and I'm going to plug in 2 for x. So we get 3 equals 4 plus b. Then I'm going to subtract 4, and we get that b equals -1. So my final equation is going to be y equals 2x minus 1. Next, we want to talk about finding the equation based on a graph. So I'm going to do something very similar to what I did on the section 3 with slope, and I'm going to pick 2 whole number points to find my slope first. So for my slope, I have to go up 3 over 1. So that means I have a slope of 3, and my y-intercept is going to be 1. So we're going to have the equation y equals 3x plus 1. Okay. Next, we're going to take a look at vertical and horizontal lines. So write an equation of a vertical line that passes to the point 3, 9. So vertical lines are always x equals a number. So x equals a number. And you always go with the x value from the point you're given, because the x value is the one that's the same. So it's going to be x equals 3. Whereas with a horizontal line, that's always y equals a number, and you always go with the y value from your point, because that's the value that's the same. So y equals -1. They're probably the easiest ones to write equations for, because it's just x equals a number and y equals a number. So the last section we took a look at was the applications of linear equations. So that's word problems. So Creed has $130 in his savings account. Each month he deposits $50. Write the linear equation for the amount of money in the account A based on the number of months M. So A is basically my y value. So we have A equals. And we need to know how much money he's putting in the bank account each month, because that's the value that's going to go with M, and that's going to be 50. So 50M plus how much he's originally started with is 130. Next, we have a water tank holds 600 gallons of water and is leaking at a rate of 20 gallons per minute. Write the linear equation that represents the tank volume, V, in terms of time, T. So we're going to have V equals, and we need to know the rate at which the water tank is leaking. And because it's leaking, we know that it's losing water at a negative slope. So it's going to be -20T. Plus how much water it currently holds, 600. Now, once I have a linear equation based on my word problem, I can then evaluate it. For our first example, I could plug in a number of months to figure out how much money he'll have. And in the second example, I can plug in a value of time in minutes, obviously, because that's the rate we're given, to figure out how many gallons of water are in the tank at any given time. So let me know if you have any questions over anything from Module 4 before your test.